Let's talk basic electronics. You're bound to work with electronic components or even circuitry down the road, so it's important to know some of the basics. Look at this. This is a breadboard. It's got this grid of holes arranged in a way that makes it easy for us to build and test circuits. Now here's a breadboard with some circuits on it. And as you can tell, it's bigger than the first one I showed you. And that's because there are different sized breadboards. And this large breadboard is basically two small breadboards put into one. So this is one breadboard. It starts from here to this hole. And then here's another breadboard where it starts from here to this hole. Actually, at the end of this video, I'll be showing you how to build a simple circuit on this bad boy. So many holes, what do we do with them? Well, first of all, what you put in these holes are electronic components, like resistors, wires, LEDs, potentiometers, IC chips, push buttons. Basically, there's a lot you can put on these things. Like a banana. That's banana bread. To build a circuit with these components on this breadboard, we need to understand how all these holes are electrically connected. These 5 holes in this row are connected, these 5 holes in this row are connected, these 5 holes in this row are connected, and so on. This means that hole A1 is connected at the same time to B1, C1, D1, and E1, but it's not connected to A2. Remember, only the rows of 5 are connected. It's also not connected to any of the holes on the other side of the gap, this gap right here. But again, the 5 holes in each of these rows are connected. The power rails run vertically along the side of the board, and each is connected along its whole length right there. The positive terminal and the negative terminal are not connected to each other, nor is this pair connected to the pair on the other side of the board. Another essential thing you need to know when working with circuits is the difference between series and parallel. This is a circuit of resistors connected in series. And you know these components, these resistors, are in series because they don't share a connection, a wire in this case, with anything else but each other. Oh, that's cute. Well, so as we see here, this resistor is connected to this resistor only by one connection. And this resistor right here, only shares this wire with only this resistor. Now if we take a look at a parallel circuit, you'll see that these resistors have an open relationship because they all share the same connection. The connection being this wire right here. And same thing on the other side. They all share this wire. Beautiful. Now let's make some series and parallel connections on a breadboard. It helps to have some tweezers on hand to make it easier to put these wires in. And we need something to provide power to our circuit. So here we've got a battery pack providing 6 volts. And so here we've got an adapter that will allow us to connect the battery to the breadboard with these wires. So here we've got our schematic, and we've got our breadboard and our batteries. So now we're going to put the positive end of the batteries in the positive rail of the breadboard right here, and the negative end of the batteries in the negative rail. Just a side note, the color black usually denotes negative and the color red usually denotes positive. I'm not going to put both ends in just yet because we haven't even built our circuit. Never have your voltage supply powering your circuit while you're constructing or adjusting it. So complete the connection with the battery at the very end only. Anyway, the battery is where it all begins. Now, if we're looking at our schematic, this drawing of the circuit is called a schematic, by the way, the first thing we encounter after the positive end of the battery is one end of a resistor. And in fact, the resistor is in series with the battery because they share the same connection and that connection only. Now, technically, you could put one end of the resistor on the positive power providing rail because they are electrically connected, so this is what it'll look like. But to prevent any mishaps when making more complicated circuits, you should connect a small wire from the positive rail to the area of the board where you're actually building your circuit. So say just any hole is fine. Now since we're connecting this resistor in series with the positive end of the battery, we're going to put one end of the resistor in the same row as the wire that is connected to the battery. So this is the wire that we're talking about, right? We're going to put the resistor in the same row as that wire. Like that. Now this is where I used to mess up all the time. I think, okay, so this row is all electrically connected, so if I'm connecting this resistor in series, I should put both ends in the same row, like this. Actually, putting it in the same row will cause a short or a short circuit. And shorts are bad because you're allowing current to go down paths they shouldn't go down. So what you should do is put the other end of the resistor in a different row, like so. Any row works. Or you could even cross it across the gap. Because remember these rows right here, they are not connected across this gap. So as long as you don't connect the other end of the resistor to the same row, you're good. Same deal for the next resistor. We put one end in the same row as the last one, and then put the other end in a different row. You could do this row, you could do this row over here, but it's easier if we just do it on the same side. And then we do the same thing for our last resistor, which is going to be this one. Same row on one end, it's connected to the previous resistor, and then a different row for the opposite end. Make sure while you're putting these resistors in, or any kind of component in the breadboard, make sure you're putting the wires in pretty deep into the holes to make sure you're successfully connecting the components to the breadboard. Good. We're almost done. Now we just need to connect the end of this resistor to the negative end of the battery. So here's the negative end, and it's eventually going to go to this rail right here, the negative rail. So we're going to take a wire, connect it to the last resistor, same row, remember? Like that. And then we put it into the negative terminal, like that. And then we complete the circuit by putting in the negative end of the battery. And we good. Now to connect these resistors in parallel, all you need to do is jump a wire from this end of the resistor, like so. And then we're going to connect it to the end of the next resistor by putting the wire in the same row as that resistor. And then to parallelly connect this resistor to the last resistor, we're going to do the same thing, jumping a wire to the same row as the last resistor. Let's see if we have space. So we're going to take it, put it in the same row as this resistor and that wire that we just connected. Put it in the same row. Now we're going to put it in the same row as this resistor. Nice. Now we're going to do the same thing on the other side. Now we just need to connect the negative end of the battery to the circuit to complete it. So looking at our schematic again, this is the negative end of the battery. What we already have are these connections, and they're already all in parallel. Now we're just going to put this wire in to complete it. So the battery is also connected to these ends of the resistors. So we put the negative end of the battery in the negative terminal, and then we're going to jump from this terminal to the rest of the circuit. It's got to be in the same row as this first resistor, or you could even put it in the same row as the second or the third. It still does the same thing. And there you've got your circuit. Now let's get lit! If you didn't understand that, we're gonna light up an LED using a simple circuit. This is a schematic of it. Here's the battery, and then a resistor and our LED. The reason why we're putting a resistor before the LED is to limit the current through the LED to a safe value. If there's too much current through it, then poor LED. It's probably gonna burn out. It is gonna burn out. Now to figure out the resistance we need to light up the LED, we're gonna use Ohm's law, which is V equals IR, where V equals voltage, I equals the current, and R equals the resistance. And these are the units, and these are the symbols for each quantity. Back to Ohm's law, we have a 6-volt battery, so we're putting in 6 volts for V. And the desired current through the LED is about 20 milliamps. You can find this on the LED's data sheet, which you can find online. So here's Ohm's law, and then we're going to rearrange Ohm's law to solve for resistance, which is R. So we have the 6 volts and we have the 20 milliamps. So 6 volts divided by 20 milliamps is 300 ohms. So we're going to need a 300 ohm resistor. And we're going to get our resistor from the resistor kit. I call it a book because it's literally a book of resistors. And as you can see, we only have 330 ohm resistors, and that's the closest we can get to 300. So that's good enough. It's a larger resistance than what we need, which is still fine. Again, we don't want to put the battery completely in yet, so we're just going to leave the negative terminal open. We're going to put a connecting wire from the positive rail to the main part of the breadboard, like we did earlier. And then we're gonna put the 300 ohm resistor in the same row. We're connecting it in series, remember? And remember, we're gonna have to put it in a different row. We can put it here. We're gonna put the opposite end in a different row. Now, since the LED will be in series with the resistor, we're gonna connect one end of the LED to the same row. Now stop.
Camera time.
LEDs have a special thing called polarity, where it'll let current go down one direction, but not the other. If you look closely, you'll see that one leg of the LED is longer than the other. This longer leg is the positive side, and the shorter leg is the negative side. So back to the breadboard. What you want to do is connect the positive side of the LED, the longer leg, this one, to the end of the circuit that's directly connected to the positive end of the battery. So this is the positive end of the battery, and we're going to connect the longer leg right here. And again, we need the other end, the negative end of the LED, to go to a different row. Now from this row, the row that we just ended on, we can jump a wire to the negative terminal. You can use either terminal, by the way, but let's put it here. So our same row, remember, we want it to connect to the LED. I'm gonna put it to the negative terminal. And then if we constructed this circuit correctly, the LED should light up.
Nice.
Now I've been using just plain wires with coding for this video, but you can be working with jumper wires just as often. They're helpful for making long stretches across or even out of the board if you're trying to connect to a device like an Arduino. This here is a male-female jumper wire. This is the male end because it has this pin sticking out of it, and the other is the female end because it has a hole. You'll find that these really reflect our bodies. Now here are male-male jumper wires and female-female jumper wires. And when you want to lengthen your connection, you just stick the male end into the female end of another wire. And you've got a solid connection. And if you ever want to build circuits or work on any projects of your own, the ECE Open Lab is the place to go. It's pretty much got all the tools you'll need. Look, we even have our own table. What up? Alright, till next time, Alyssa out.